Okay, so welcome back. Now in this example, we're going to do the same example we did last time, except now we want to estimate the length of the curve. So we've got this function over this interval, and we want to use M6 to now estimate the length of the curve over that interval. So now we're going to use the arc length, right? So now we're talking about arc length. And so we're going to use the formula for arc length. And so remember, in this case here, what we want to estimate is the integral from 1 to 4 of the arc length formula. So the arc length formula, again, is the square root of 1 plus f prime of x quantity squared dx. That's what we want to estimate. So we're going to estimate that by using the Riemann sum. Okay, so now also note that the derivative dy dx is x. Is x. Okay? So this is going to give us the integral from 1 to 4 of the absolute value of 1 plus x squared dx. Okay, so that's what we want to estimate. Now remember, our midpoints that we found was 5/4, 7/4, 9/4, 11/4, 13/4, and 15/4. Okay, so those are the midpoints. So we're going to estimate this arc length by using the Riemann sum. So we're going to use the sum from I equals 1 to 6. But instead of using this function like we did before to estimate the area under the curve, so we're going to use the arc length formula. So we're going to use this to estimate 1 plus x squared, right? Times delta x. Which again, remember delta x in this case is 1/2. Okay, so we're just using the information that we found before. Okay, in the last problem. Okay. So same setup, but now we're using the formula for the arc length, and we're going to add up the arc length for each subinterval, right? Using the Riemann sum. So again, this should harken back to the way we developed this arc length integral in the first place. Okay, and so now what we're going to do is we're going to plug in each one of these values for this sum. So this is going to equal, again, I'm going to pull out the delta x because it doesn't have anything to do with I. So this is going to be 1/2 times the sum of what? It's going to be 1 plus m sub I squared for I equals 1 to 6. So that corresponds to each one of these values. So I'm just going to plug in each one of these values. And again, in this case, you would use the calculator. Okay, I would definitely use the calculator because we're dealing with a square, and then we're dealing with a square root. So this is not going to be very pretty. Okay, and most of them aren't. Okay, the last two examples just turned out to be nice. So if you stick this in your calculator, what do you get? You get 1/2 times, so this is going to be approximate, Okay, and then of course this is going to be approximately equal to, or equal to. And so that's what we get for the approximation of the arc length. Okay, so now here's one for you. Again, just follow the same steps that I've been doing. So estimate this one. So use the midpoint rule. And use n equal to let's do 4. Let's do n equals 4 and estimate the integral from 1 to 2 of 1 over x dx. Okay, so do that one. Use the same thing. All we're going to do is estimate this integral with 4 subintervals using the midpoint rule. So basically find m sub 4. Okay? See you next time.